Hello, my mathematical lovelies. I know that in the last video I incorrectly reported what chapter I was working on. Hey, we're in chapter 8. So today might be a little easier and a little rough for some variety of reasons, but we're going to be doing the quadratic formula. So the idea is that if you have any quadratic equation in the following form, it's actually called standard form. And we wrote that yesterday, or not yesterday, I didn't see you yesterday. Not seeing people is weird. Which is that ax squared plus bx plus c equals 0. So notice one side has to be 0 to do this. Then it has the following solutions. X equals the opposite of b plus or minus big ol' square root b squared minus 4ac all over 2a. And I'm going to fix that opposite of b because that looks a little bonk. Minus b. And all of this is under the roots. You got to be careful. Okay, so, take a look at that guy. That's a something, isn't it? Have you seen it before? Back when I was a student, I memorized it using Pop Goes the Weasel. So Pop Goes the Weasel goes, all around the mulberry bush, the monkey chased the weasel. The weasel thought it was all good fun. Then pop goes the weasel. Just in case you've never heard that song before. So how you do it with the quadratic formula. I know, it's my singing voice, I'm sorry. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I'm so sorry I did that. Yep. So we're going to be using this today to solve quadratics. And then at the end of the video, I'm going to show you where this formula came from. And that, my dears, is an adventure. So if you get to the end of using this and you're real curious and you want to see where it comes from, I'm going to show you that. For those of you who get to the end and you start watching it and find it really confusing, you don't need to know it to use the formula. Just know it comes from completing the square and then solving for x. So following the same steps we did in the last video in 8.1 where we completed the square and then used the zero factor property to solve, same stuff. So this does the exact same thing as that, but does it in one step. So I'm going to be using this today to solve some equations. So like I said, if you didn't like yesterday, today you might like better. I shouldn't say that. If you didn't like the last lesson, you might like today's better. So we're going to solve by quadratic formula. And I've got a bunch of these. 2x squared minus 5x equals 3. Starting right off the bat, I've got one that's not right. It's not ready to be quadratic formulaed. What do I mean by that? Well, it doesn't have one side 0, so I gotta subtract 3 to get my stuff over. One thing that you really need to be careful about with this is you need to really watch your signs, because if you mess up one, oh boy, does the formula come out gross. So be careful. So here, A is going to be 2, B is going to be negative 5, and C is going to be negative 3. So I'm going to write that down. And then I'm just going to use the formula. X equals the opposite of B, so since B is negative 5, I'm going to get plus 5. Go ahead and write B, teacher. Plus or minus the square root of B squared, so negative 5 squared, minus 4 times A, which is a 2, times C, which is a negative 3, oof, all over 2 times A. All right, now we need to do some calculating. So plus 5, I'm just going to write as 5, sorry. That's a little silly. There's the plus or minus we saw coming up in the zero factor, or not zero factor property, the square root property that we saw last time. I made that way too big. Let's just shorten it up a little. Negative 5, when you square it, you'll get 25. And then I got to do this. Oh boy. So negative 3 times 2 will give me negative 6 times negative 4 will give me plus, wait, yeah, 24. I don't know why I second guessed myself on that one. All over 2 times 2, which is 4. Now I'm going to need some more space. So I suggest when you write these out, if you are worried you're going to forget this formula, write it out every time. So write out the opposite of b plus or minus square root of b squared minus 4ac all over 2a every single time, and then fill in all your stuff after you write down what a, b, and c are. And then you won't make any mistakes because you've been thorough. Okay, 25 plus 24, better give me 49 all over 4. Now hopefully you know your perfect squares well, and you know that the square root of 49 is 7. So this actually becomes 5 plus or minus 7 over 4, which we can reduce. Now, if you can reduce the square root, I would actually suggest you write two versions of this. It gives you two answers. It gives you the plus version, 5 plus 7 over 4, and 5 minus 7 over 4. So remember, when you see that plus or minus, it's really telling you there's two answers. One's for the plus, one's for the minus. So 5 plus 7 better give me a 12 over 4, totally a 3. And then 5 minus 7, negative 2 over 4, totally a negative 1/2. And that's it. We've got our two solutions. So if you wanted to, you could write this as a solution set, 3 comma negative 1/2, like we did at the beginning of class, but that's not really necessary. This is probably good enough. You've established what your two answers are. And that's it. Done. You might like this better than the previous way we did this using the square root property and such. You might like it more. It's only one way to find out, and that's to practice it. So let's do 3x squared minus 2x plus 3 this time is 0. So looking at this guy, let's set up our a, b, and c. Let's see. A is 3, b is negative 2, and then c is 3. All right. Let's watch our signs and be careful. What's x going to be? It's the opposite of b, so the opposite of negative 2 will be a positive 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a times c. Ooh, my a and my c happen to be the same this time. I wonder if that's going to do anything fun. Only one way to find out, and that's to keep going. And then all over 2a, 3. Let's do some simplifying. So 2 plus or minus the square root of 2 squared is 4. Make these a little bigger, kind of hard to see. Minus, oh boy, 3 times 3 will be 9, times 4 will give me 36. Or I could do this as 4 times 3, which is 12 times 3, and that'll give me 36 also. Don't need a root that big. And then 3 times 2, that'll give me a 6. I'm hoping this gets nicer over time. P.S. It's not going to. All right. 4 minus 36. Square root of negative 32. Uh-oh. This is going to have some i's in it. Here we go. So 2 plus or minus, let's see, I'm going to have to do the negative square root thing, so I, and then the square root of 32, which that's not going to factor nicely. So I'm just going to leave it in there, but it's even. Let's see, what could I do? 32 is 16 times 2, I believe. Let me think. I need to do my factoring in my head. I believe it's 16. You divide it in half, you get 16. Yeah, so it's 16 times 2. So I'm going to do this as 2 plus or minus, let's see, I'm going to reduce my square roots. So this is going back to all the way back in chapter 7 when we reduced roots. 16 times 2 all over 6. I'm doing this for a reason. See, 16 square root will be 4, but 2 isn't going to get square rooted, so we'll get 4 square root of 2i. Ew. Couldn't get any nicer than this. Aha, everything here is even, so I can factor a 2 out of my numerator. Get 1 plus or minus 2 square root of 2i all over 6, and I can reduce that down to a 3, but that's as nice as we're going to get. Did not want to do that. Does it make you guys nauseous when I zoom? I don't mean to. Okay, so now we got to write this. I have 2 of these. I want to write both of them. So I'll have 1 over 3 plus 2 square roots of 2 over 3i. So that was the plus version. And then 1 over 3 minus 2 square roots of 2 over 3i. Oof. Rough, to say the very least. Yep. Be prepared. Your eyes might show up. You might have to deal with roots. It could happen to you, man. Hopefully you're seeing where I'm getting all these parts from. Everybody's divided by 3. I don't know if this was all that clear. I hope it was okay. Feel free to let me know. Let's do another one. 3x squared plus 16x equals negative 5. I don't remember how this one comes out. Let's find out. Let's go green this time. First of all, got to make one side 0, so I'm going to add 5 to both sides. I feel like the green isn't as visible. Wonder if I make it darker green. Nope, no options. Too bad. So I have 3x squared plus 16x plus 5 equals 0. The eraser, when it works, it's wondrous. So my A is 3, my B is 16. That's a big B. It makes me a little scared. And my C is 5. I'm very worried about this. We'll see what happens. Okay, so what's x? It's the opposite of b, so negative 16 plus or minus the square root of 16 squared minus 4 times a times c. Careful, make sure your parenthesis looks round and not like a 1, all over 2 times a. Oh boy. So, yep. This is going to get big. This can happen, you know, stuff. It'll be okay. Let's see. Opposite of 16 all over plus or minus the square root of 16 squared, which is 256. That's me doing it in my head slowly. Minus 4 times 3, which is 12, times 5 will totally just give me a 60. That's not bad. Still kind of big, and I'm worried. 2 times 3, 6. Opposite of 16 plus or minus, and now I got to do my subtraction. So take 256 and subtract 60, and you'll get 192. Or no, 196. Where was I getting 2 from? It's wild. Is 196 a perfect square? I think it is. I think it's 13. Let's find out. I'm going to pull out my calculator real quick and do the square root of that. It's 14. How was I 1 off? That was super weird. Anyway, so this is another one that comes out kind of nice. Plus or minus 14 over 6. Don't forget about your calculator, folks. You totally can use it. Especially when you see a big one like this. It's worth a try. If not, my next move would be to factor this. So that's got to have something in it I can factor out. Okay, so I'm going to write this twice. Negative 16 plus 14 over 6. I don't like how I did it last time, so I think I'm going to do it this way. Negative 16 minus 14 over 6. So then I'm going to do these each individually. So I'm going to add my numerators together because I can this time. Now, careful. You can't always do that, as for what we've seen so far. If you have a bunch of i's everywhere and square roots, it's not so good. So this first one's negative 2 over 6, which I'll reduce in a minute. And the second one is negative 16 plus a negative 14. Be careful, this is going to be super negative. Why am I having a brain fart on this? 4 and 6 makes 10, and then another 10 and another 10 is 30. Oh, that one comes out kind of nice. It's negative, but it's kind of nice. Not an eraser, thank you. Why am I doing another comma? I don't know. Why am I talking to myself in a room by myself? Oh no, they're both negative. That's okay. Since these are both even, I reduce them both by 2. And then 30 divided by 6 is totally just 5, which is nice. But don't forget your negatives. I know some of you like to drop your signs like it's hot. Don't do that. So there's my 2 values of x. So there's my 2 solutions. Woohoo! I have lost track of which number I'm on. I think I just did C. I did just do C. Let's do D. Now D, I would do by completing the square, to be honest. Because it's already set up to be done by completing the square, right? It's got these 2 on the side by itself, but I want you to see one where we could have done and probably should have done completing the square. But you can still use the quadratic formula. The other thing that cues you into that you should probably complete the square is there's no a is, 1. And usually with the ones where a is 1, we'll use completing the square. So my b is 6, and I have screwed up. I made a big no-no. I didn't make my other side 0 first. Bad teacher. I'm just kidding. I screwed up on purpose so you'd remember. Hopefully you were yelling at the screen, no, you gotta do this first. Stop. What's wrong with you? Why aren't you doing the thing that's right? I'm gonna add my 13 over first so I have C. but silly me, I would have totally completed the square on this one. 0. Cool. All right, now let's do ABC. A is the coefficient of x, which is just a 1. B is the coefficient of the x term, not the a. Oh, this was 1 for x squared. Why did I say x? And then C is 13. Why am I writing huge? Don't ask me. I'm in charge. Opposite of B, plus or minus the square root of b squared minus 4ac all over 2a. Clean up your root because it's a huge one again. Doot. Let's do some multiplying. So negative 6 plus or minus the square root. 6 squared is 36. Minus 4 times 13 better give me 52. I'm double checking myself on that one. It is 52. Ooh, gonna get a negative root again. 2. I know that because my 52 is bigger than my 36. When that happens, we get complex numbers. So negative 6 plus or minus 36 minus 52. My 5 button doesn't want to work. Ooh, negative 16. That's kind of cute. All over 2. So I'm going to real quickly fix this up. Negative 6 plus or minus, since it's a negative root, I'm going to have an I. Square root of 16. 2. Let's roll her up again. Negative 6. Hopefully you know the square root of 16 is 4, so I have 4i over 2. Let's split the numerator. So I can reduce both these. Negative 6 is negative, over 2 is negative 3. Plus or minus 4 divided in half is 2i. So I really have two solutions here. My x is either negative 3 plus 2i, or x is negative 3 minus 2i. Hopefully you enjoyed. And you might recognize this problem from the previous lesson, because I totally did it in that one too. I like it. I forgot where I was at again. I'm on E! 9x squared. When in doubt, try a big one. Minus 6x plus 1 is 0. So this one's going to come out a little weird because my a is big this time, but my c is small. So hopefully we'll be okay with that. My a is 9. My b is negative 6. And my c is 1. Let's see where this one goes. One thing that's nice about this one is I haven't done it ahead of time, so we'll see what happens. Alright, opposite of a negative will be a positive 6. Plus or minus the square root of b squared, so negative 6 and then square it, minus 4ac all over 2 times a. Okay, I haven't cautioned you about this before, but notice with the negative b's, I have been using parentheses to make sure that if you do enter it into your calculator, you don't enter it in incorrectly. Some calculators, if you do negative 6 squared, will square first and then do the negative and give you something like negative 36 off this. But be careful, it's actually negative 6 and then squared, the whole thing squared. Just a good caution thing to watch out for. Let's do some calculating. So 6 squared is totally 36 minus 4 times 9, which is also 36. We haven't had this happen yet. Uh-oh. Why do I do this? Make the giant root when I don't need it. And then 2 times 9 is 18. Okay. Now, square root of 36 minus 36 is 0. Oh my gosh. What's the square root of 0, guys? That's right, it's 0. Why do I want to change this to a 16? Stop doing that, crazy teacher. So what happens here is, well, as you look at this, I'm adding and subtracting nothing. So I get 6/18, or 1/3. This can happen to you. You also can get only one solution. Okay, so if you're wondering why is this happening, it's because when you look back at 9x squared minus 6x plus 1, you can factor this into 3x plus 1. Sorry, it's 3x minus 1 and 3x minus 1. So if you'd have done this by factoring, you would have gotten your two solutions as the same thing. It would have been 1/3, which is kind of fun. Or you can do the quadratic formula. Good times. So one thing I want to do before I get into summarizing this stuff. You now have a ton of methods for solving quadratics. And I want to take a minute to summarize them. So the first method you have is by factoring. Factoring is very good if your answers are real. Oops, that doesn't look like words. The second method you know, we just learned last time, which is using completing the square. So the one this works well for is really if a is 1. Or you can divide by a. And even then, completing the square it's a little rough, to be honest. And then the last one is using the quadratic formula. This one, I think it has some advantages. It always works, but it's a little slow. Good, but slow. So you notice each of those problems took me like a while to get through. I only did 5, and like it was a bit of a mess, to say the least. The other thing I would warn you about this as you look at this is there's 3 options for solutions. You could end up with 1 real number, 2 real numbers, or 2 complex numbers. If you get anything else, you've done it incorrectly. So this is another thing to like watch out for. So if you're doing this along and something crazy happens and you get like a mix of a complex and a real, you've made a mistake. So be careful. This is one thing to watch out for, and that can help you in solving these. Okay, so next I'm going to do how you get the quadratic formula, which not all of you need to know at all. If you want to watch, that's great. I'm never going to ask you anything on this, so don't freak out when you see it. Because it's a little rough. Let's just put it that way. So where did x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a come from? And like I said, if you want to watch this, that's awesome. If you don't, maybe, I don't know, pause the video and don't continue watching it. So we're going to start off with a times x squared plus bx plus c equals 0. And I'm going to complete the square on this and then solve it for x. And I know that sounds insane. Okay, so I'm going to start this from standard form. Ax squared plus bx plus c equals 0. So the first thing I'm going to do is I'm going to move c over to the other side because I'm going to be completing the square. And that'll give me ax squared plus bx equals negative c. Now let's just go ahead and divide everything by a so that I have x squared in the leading term. So I'm going to get x squared plus bax equals negative c over a. Cool. Come on. I want a red. Why is it doing this to me? Because it's mad at me today. Cool. So now I'm going to do the missing number bit to get a perfect square and complete the square. So who's missing? Well, normally what you do is just take the thing in front of the thing in front of x and divide it by 2. So b over 2a. And then we square it. And that's what we add. So b squared over 4a. Hopefully you're seeing that 4a and thinking, I know where this is going maybe. So I'm going to add that to both sides. I'm going to roll her on up. Here we go. So this together is a perfect square. X plus b over 2a squared equals, and now I got to do the other side. So negative c over a. Actually, let's switch the let's switch the direction of this. So I'm going to do b squared over 4a on this side, and then minus c over a. Because the next thing I need is I need a common denominator. So this has a 4. I have an error. This has a 4a squared. Come on. Why does it do that every time I go near the pen? So to get c to have the correct denominator, I need a 4a over a 4a. So this ends up being b squared minus 4 times ac, 4ac, all over 4a squared equals the perfect square x squared plus b over 2a squared. All right, and here's where you're going to use the square root property, and this is where it gets a little bit more wild. So this means that x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now I'm going to split this root. So that means I'm going to do x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over the square root of 4, which is 2, and the square root of 2a, which is a. Get it? And then I just got to subtract b minus 2a over. Then I get that x is negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And the last thing we notice is, oh, they have the same denominator, so we'll just combine them together. Negative b. I did it again. I keep doing that with the negative. Come on, eraser. Negative b plus or minus the square root of b squared minus 4ac. Isn't that wild? So that's where it came from. It's the exact same steps we took, whether you realize it or not, when we use the zero factor property, I keep calling it that, the square root property after completing the square to solve. These were all the steps you did, and that's where the quadratic formula comes from. So, strength in understanding, hopefully. If not, sorry you watched this. I'll make sure that I try to not show you as much stuff next time. I don't know. Actually, next time we're going to use this to do some stuff. It should be kind of cool. Mostly it's with graphing though, which is kind of fun.